Alkanes and Alkenes exercise 2. The structure questions, we did the first three, and we'll do question 4 onwards. This is question 4 related to alkanes and alkenes. The table shows a structure of 4 hydrocarbons, P, Q, R, and S. Why the compounds are known as a hydrocarbon? What is the reason why we call them as a hydrocarbon? Because they contain carbon and hydrogen only. Because they contain carbon and hydrogen, that's why we call them as a hydrocarbon. P is a saturated hydrocarbon. So what is meant by term saturated in terms of hydrocarbon? It means it contains single bond of the carbon between the carbon atoms. So because there's a single bond throughout the structure between the carbon atoms, that's why we call them as alkane or a saturated hydrocarbon. P undergo a substitution reaction. What is meant by the term substitution reaction? So compound P, as it undergoes a substitution reaction, what is the definition of a substitution reaction? Substitution reaction is actually when atom or a group of atoms replaces the other atom or the group, we call that as a substitution reaction. So one atom or group replaced by another atom or a group. So reaction in which one atom replaces the other atom. State the condition required for this reaction. So this is a photochemical reaction. So we need a UV light. Or write a chemical equation. So how to write a chemical equation? We have to check what is P. P is C2 and H6. So if it is C2H6 and it is reacting with chlorine, so C2H6 plus Cl2, what will happen? One chlorine will replace the hydrogen and one hydrogen will be take position of a chlorine. So this will turn into C2H5Cl plus hydrogen combined with chlorine, so it will be HCl. So C2H6 plus Cl2 gives C2H5Cl plus HCl as a product. Compound R undergoes addition reaction with bromine. Why this is addition example of addition reaction? The term addition reaction means we'll have only one product formed. That's why we call that as addition reaction. Compound contain bromine is formed. Draw the structure. So when R is reacting with bromine, addition reaction is there. So this is R. So what actually happens when any alkene react with a bromine? So the double bond will turn into a single bond and the two bromine attach to the carbon. So it means what will be the product when R is added or reacted with bromine, Br2? So one bromine added with the carbon, like each carbon will have a bromine. So as a result, the product will be CH2 is there. So we write this. Then there's a Br. And the second one is CH. Then there's a Br. And then we have a CH3. So always remember, whenever any alkene react with a bromine, the product will be, the double bond will turn into a single bond and each carbon which was having a double bond will a bromine atom attached. In question 5, the structure of 5 alkenes are shown. What is the general formula for alkene? What the general formula for all the alkenes? Because the number of the hydrogen are always twice as compared to carbon. So if the carbon are N, the hydrogen will be 2N. What is the molecular formula of alkene D? The molecular formula means the actual number of atoms in D. So we just have to count how many carbon are there. Even if you know the carbon, you can write for hydrogen because the hydrogen will be twice. You can count that as well. 1, 2, 3, 4, 5. So we have 5 carbon. Then how many hydrogen will be there? Because hydrogen should be double. So it will be 10. You can count, it will be 10, like 3, 5, 7, 8, 9, and 10. Or you can also directly write it. Predict which alkene has a highest boiling point. The boiling point depends on the number of the carbon. So which has the highest number of the carbon? E is having the highest number of the carbon. So E will have the highest boiling point. So we'll write E, and the reason, because contain greater number of the carbon atoms. Which is most likely to diffuse, so lighter molecules diffuses faster. When we check which has a least number of the carbon atoms or the smaller mass, that will be A, as it contains only 2 carbon atoms and has 4 hydrogen atoms. So it will be A here, and the reason it has a lowest mass. In E, the student added an aqueous bromine to alkene C. Describe the color change where alkene, if you want to test the alkene, we can use this aqueous bromine. And what is the observation? If aqueous bromine is added, it will turn from orange to colorless. And then the structure, as I mentioned, whenever alkene react with bromine, the double bond will break. So first we will draw the same structure. The double bond will break. And we have to show all the atoms and all the bonds. So if it's written CH2, then we have to show that this will be CH2. And then next to that is CH3. So this is CH3. So when it react, alkene react with the double bond will break. So we draw the same structure, but double bond should not be there. And then what will happen? The bromine is added to each carbon. So this will be Br. This will also be Br. You can attach any side. That will not make difference. It can be attached from the bottom or towards right or left. That does not make difference. But the carbon atoms which are having a double bond, they will have these 2 bromine atoms. Two different alcohols can be produced from alkene B. Draw the structures of the alcohol. So what we can do, because as it is a propene, so it can produce propane 1-ol or propane 2-ol. So we can draw the same structure. The position where we attach the OH, and we have to show all the atoms and all the bonds. So first we draw without a double bond, and the OH we have to attach. So we can attach with the first carbon. If OH attach with the first carbon, hydrogen attach with the second carbon. The second possibility, this will be propane 1-ol. We can draw propane 2-ol. If the OH is attached with the second carbon and H is attached with the first carbon. State the reagent and the condition need to produce an alcohol from alkene B. So what are the reagents? We need the steam. And the conditions, we need a catalyst, phosphoric acid. And high temperature. You have to learn these conditions. You can mention like 60 atm pressure and 300 degrees centigrade. Instead of just writing high temperature, you can also say 300 degrees centigrade and around 60 atm atmospheric pressure, 60 ATM, the atmospheric pressure. In question 6, propene is an unsaturated hydrocarbon. The formula for propene is shown. The color, what we'll observe if aqueous bromine is added. So whenever we add an aqueous bromine, the aqueous bromine changes its color from orange to colorless. Propene can be produced by cracking a long chain alkane, pentadecane is there, and it produces an alkane and a propene in a ratio of 1:2. Like it will produce propene, 2 molecules of propene and 1 molecule of any alkane. So 2 molecules of propene, so 2 molecules of propene, prop means 3 carbon. So C3, C3H6. Because it's an alkene, so the number of hydrogen. Now, how many carbon? Now, what about the alkane? You have to complete a structure. 2 multiplied by 3, 6 carbon atoms. Out of 15, 6 are used here. So this will be 9 carbon. And out of 32, we use 12 here, so it will be 20. So C9H20 will be the alkane, which is a nonane because of the 9 carbon. And we have the 2 molecules of propene. So how we complete this? We just count like total are 15. Out of 15, 6 are used here. So remaining 9. And about the hydrogen, we have 32 hydrogen atoms. Out of 32, we use 12. So we are left with 20. Propene can be converted into polypropene. Name the type of polymerization. So it's always an addition polymerization. Then draw the diagram to show a section of a polypropene. First, what we'll have the propene 3 carbon atoms, and the first 2 will have a double bond. We just have to draw the structure, the section of the polymer, but propene, this will be the propene, C double bonded with CH2, double bond CH, and then CH3. When we rearrange the structure, so it will be C double bonded with O, or C double bonded with C. This will have 2 hydrogen. This will have 1 hydrogen and then CH3. And when we draw the polymer, like this is we rearrange. The second thing we rearrange. It's the same thing, but we rearrange the structure. And then when we draw a polymer, we draw the same structure, but without a double bond. This is one unit. This is the second unit, and we link them together. That's how the polymer will form. So same thing we have to do. Like this will have 2 hydrogen. This will have 1 hydrogen and then CH3. Then this will have 2 hydrogens. And this will have 1 hydrogen and CH3. Is it clear? Discussion? So this is an exercise related to alkanes and alkenes. Exercise 2. And I will share this exercise as a weekly homework. And the next week, I will completely discuss the remaining questions. It's about 13 questions are there in this whole exercise. So you have to send before Saturday next week. Any question or doubt related to the session today?